Much like with the section views that you've been creating over the past couple days, you had to make those section views because I told you to. And if you didn't, so like with section views where you had to create them just so you could detail out internal features, or just simply so it would be easier to detail out the view or make it clearer to why or what the part was even doing or its purpose. There will be instances where you'll need what is called an auxiliary view. And when you'll need an auxiliary view is when you have an inclined surface or an oblique surface, which is when the surface is not perpendicular or parallel to any of the principal views. Incline is just not, in certain views, it's not perpendicular or parallel to, but it can be to some of them. So I have a simple part here that has just a simple inclined plane on it. Generally, if we've run into those, but they've just had an inclined plane and you could just dimension its height and width and angle and whatnot. But in this case, it has 4 holes, if I can orient that to the camera better, on the inclined plane. In order for us to fully detail these holes, we can't use the top, right, or front because they would appear, well, in the front obviously you're not going to be able to see them at all except for the hidden lines, but the top and right, they're going to be kind of skewed, and basically they'll, in order to even create them, you have to use an ellipse. So that's where the auxiliary view will come into play. I will show you how to create that auxiliary view in SolidWorks and AutoCAD. I'm going to start with SolidWorks because it's just as simple as clicking on a button in SolidWorks to create an auxiliary view. You have to go into a lot more effort to create an auxiliary view in AutoCAD. So I'm going to swap over to SolidWorks now. So here is my model, that little part that I showed you in SolidWorks. I'm going to cover how I did this. If you come across a part where you need to, well, we're going to be doing this. So if you want to use that method where I kind of sketch everything out first and then do all my solid extrudes and cuts, you'll probably need to use planes. To create a plane, it's underneath the Features tab, and then it's Reference Geometry. So clicking under Reference Geometry, I have Plane. I click on Plane, and what I did to create this is I want a plane that's going to be about this line here on my sketch. That's going to be basically perpendicular to the sketch plane, which in this situation is the front plane. So I click on the line with either one, and then I come to my second reference and I do the drop down right here, a little arrow, and then I'm going to click on front, and then that will automatically select perpendicular as my constraint type. I can switch these out if I want it to actually be like an angle to that, say 45. I have a lot of options there, but in this case I just wanted it to be perpendicular. So it's constrained coincidence to this line and then perpendicular to the front plane. And then from there I can select it, do my sketch, put my holes on there, and do my cut from that. So that's if you don't want to use the plane and just do the holes after you've done the solid extrusion, then you can just click on the surface, do your sketch, and plop those sketched holes on there. So I'm going to swap over to the drawing real quick. And now I already started this up, so I got my 3 views in here, and I want my auxiliary view looking at this inclined plane right there. So I just come up to my view layout, click on auxiliary view, and then it says please select a reference edge to continue. So I want to use this as my reference edge, and now it just projects out the auxiliary view. I place that there. If I want to, this is the view plane line. It's very similar to the section line. You can kind of move these around, get them positioned so you can dimension around them or whatnot. The view itself is locked into projection with the view that you referenced. If you need to break that alignment, you can just simply click on the view, right click on the view, come down to alignment, and click on, break alignment. Now this view is free to move around. It's got the labeling of view BB and the plane, so it tells you what it is. If you want to then also rotate it so it fits better, you can come up here and do rotate view, and then clicking on it or typing in the view, it'll rotate it around. As you can kind of see, as I rotate in one direction or another, it will start flipping the symbol here. So that's rotating. Lets the people know what way it's rotated. That symbol is, I have not quite found it in AutoCAD yet. It might, hopefully this isn't the case, but the worst case scenario, we're going to have to just create an arc and then a fake arrowhead or something like that so we can plop it onto our drawings if we come to the need of rotating the view. Okay, I'm going to swap over to the AutoCAD side and then show you how to do the same process in AutoCAD. So I already have this mostly sketched out. I just haven't finished up the holes in the right and top view. I'm not going to completely finish them, but I'm just going to show you how to get those finished, and then I'll go into how to create the auxiliary view. I imagine most of you have already done this, but just in case you haven't, to create that hole that's on that inclined plane in, say, your top or right view, you're going to need to use an ellipse. So as I said, all you need for that is the center of the hole and the top or the bottom of the hole. So I have my construction lines here projecting from the bottom and the top. I colored them green so I know what I'm looking for on the top view, and then I have one coming from the center of the hole, which I colored red, once again so I know where the center of the hole will be. So I'm going to come up to the top view. I'm going to type EL for ellipse or EK for not ellipse. Here we go. Press enter, and then I want to use my center, so I'm going to right click center, click here, go up to the width, which was it's a radius of 1/8, and then come up to the top of the hole. And it's just that simple. And then I'm just going to quick copy these over. And there we go. The hole comes through the inclined plane and out the back side of this part, which that will also create an ellipse. If you can see here, got it kind of highlighted, an ellipsy kind of shape. Same process. I need to know either the top or bottom of the hole. So I'm going to copy this line here, go to the top of the hole, and then I need to know the center of the hole. Copy, and I'm going to go to the center. Now I can come over here, I already got that all laid out, type ellipse again, right click, center, go to the center, go up to the top, and go to the width. And then on this situation, this would be hidden, so I'm going to make it hidden. So I can finish this off. I just need to put my lines going down to, same thing with that, do an ellipse there and connect it with lines, so on and so forth. We've already done most of that stuff. So now the auxiliary view, I am projecting lines perpendicular to the plane that I want to be looking at. And now, so that gives me all those sizes. And then the other thing I need now is just my depth of the part, which I can get from either my top or right view. I'm going to use my right view. I'm going to move these lines for my widths. I'm going to actually copy them. Get myself a base point, and it doesn't really matter where I put it. I'm just going to plop it here. It's got some constraints on it, which I'm going to kill. And now I just need to rotate it so now that these lines here are perpendicular with the projected lines from that inclined plane. So selecting a base point, or I'm going to quick select them all, rotate, base point, and As you can see, there's nothing really snapping to it. Actually, can I go? I'm gonna try one thing here real quick, and then I'll show you the other way I would do it. Okay, so now I just did a near constraint there, typing NEAR, and that seemed to work. The other way to do it is to rotate it, select your base point. I'm going to do a reference. So now I'm rotating on that line itself, and then now I just need to do a perpendicular, which I can type in PER or right click, snap overrides, perpendicular, and then click on any of these lines, and now it's good to go. So now I can just start filling in the dots, basically. If you want, you can start, as I did with these other things, start coloring things where the holes would be. You can color all these. Come up to your home tab over here, or in your properties, you can change out the color. I'll make these a green color, center line, make those red. Now that kind of matches up with what I had up over there, so I can just do a circle. Here's the holes. Oops, I screwed that up. Copy that over. Click on line. Again, like I said, just connecting the dots. Making sure you actually hit everything you needed. I do believe this one here is my hidden line that I'll need on there. Yep. And then the last step, just as you would do with your section views in AutoCAD, draw your basically a cutting plane line, but it's a view plane line. Place it parallel to the inclined plane you're trying to look at, and put your multi-leader arrows pointing perpendicular to that line you just drew in, pointing at the inclined plane you're looking at. And then with the text tool, just put A, B, C, D or whatever, and then label this view here. I have this up here. We can move that down here, rotate it like I was doing in the SolidWorks file. This is a fairly simple part, obviously, so these will get a lot more complex. Kind of take it a bit at a time, create more construction layers, as I was doing here, color things to make sure you keep track of things. I'm going to have you do full sections where you do the full part. There's probably more likely that you'll just do a partial section where you just do the plane that you're trying to get to detail out and maybe just a little bit more. But just to get a handle on the process, I'll have you do the full sections on these. Nothing that I assigned is terribly difficult, but they're all up on Canvas now. The last three, I'm going to have you trade off with another classmate to do the SolidWorks side of it, and then we'll keep on moving forward.